Alright, and we're back. We've got some voltage chart sitting across the capacitor. I've got the capacitor at full voltage at the moment. If I discharge it, what should happen to the voltage on here and why? It decreases to 0 because I've taken all the charges away from both plates. When I close the switch, what should happen to the voltage on the capacitor and why? Should go up. I'm charging it. Yay, it goes up. It's fast at first, then slower. And then I can release that. What happens to the charge on the inductor when I close this switch? It starts off really big and then decreases. There's not as much potential difference as there is once the current is flowing, because the current is flowing. But at the start there is the biggest change of current. So there's the biggest induced voltage against that. That's called the back EMF. The back EMF is what inductors do to oppose change. So in this simulation, it works when I close the switch. We get a sudden, immediate from 0 to something change in current that induces the biggest possible back EMF. Note how tall it is. It's just about 9 volts, but if it stays at 9 volts, there'll never be a current. So it's just below 9 volts, and as the current gets pushed through and stabilizes, we can see that the voltage in the inductor, or voltage across the inductor, has reduced down to 0. Let's have another look at what happens if I change the impedance, or the inductance. Sorry. If I increase the inductance, this means there's more turns. So whatever current goes through this loop, there's going to be that many more times. It was from 5, so now it's gone to 10. There's going to be double the time constant. If I close this, the voltage will go up half the speed. Sorry, it will go up the same speed, but it will come down at half the speed that it did before. If I only have 1, 2, 3 loops now, that back EMF will go straight up to the supply voltage and then almost immediately come down. Pow! Can hardly even see it. If I increase the inductance while it's going, there's no change in current, so there's no back EMF. Nothing at all happens to the voltage. Let's close that again. We're expecting peak EMF, slow reduction in voltage as the current slowly builds up. And there's our slow reduction in voltage. And the current, I can actually measure the current, can't I? Slow reduction in voltage as the current builds up. Voltage down as the current builds up.